Good morning, statistics. So I wanted to do a follow-up to yesterday's day one video to dive into the mechanics behind the hypothesis testing a little bit deeper. I kind of glossed over it yesterday and I really want to get into the heart of it. So here we go. If you recall from Mr. Nystrom that the first step of the hypothesis test is to state your null hypothesis, which is what we believe to be happening if chance were actually going on, and that is what we set for whatever our population proportion is going to be our null hypothesis. It's always in a statement of equality. You'll see an equal sign in here. And then we read the problem to determine what our alternative hypothesis is. It could be one of three things. It will either be greater than or less than. Those are called one-tailed tests. There's a lower one if it's less than, there's an upper one if it's greater than. Or it will be considered a two-tailed test, and that's if you state that it's not equal to something. So that's our first thing, calculating and stating the null and alternative hypothesis. Step two then is we're going to make the null model, and we're going to use P, the population proportion, as our mean, and it's basically just a sampling distribution, and we calculate the standard deviation, which you'll see here coming up in a minute. And then after we do all of that, we look and we see what our z-score would be after we use our sample proportion and our population proportion. We'll go through, we'll calculate the z-score, and then we'll decide if we're going to reject the null because it is so statistically significant, it's in the tails, or we will fail to reject the null, which means it was not unusual. All right, so let's remember a couple things. The null model is the sampling distribution with a mean of p. That's exactly what we just spent studying in the last chapter. Remember, all the samples you take, most of them are going to lie, the p-hats are going to lie near p. So once you know p, you could then create your standard deviation using the formula here, which is just the square root of pq over n. Okay, remember that we are looking to try and find some evidence that our null hypothesis, which we have stated to be true, is actually not true. So we draw that null model and we look to see if what we get in our sample proportion is far away from what we believe could be happening just by chance alone. All right, so once again, there's that picture. So if it's within the, under the clump in the hump, if you remember from our cartoon guide, then if it's within that 95%, we won't be that surprised. Okay, so here we go, the mechanics. So they're going to give you some sort of sample. So the problem that we were studying here were if students actually go and pass the test at the DMV. So here we go, we sampled 90 students and 61 of them passed. So in our sample, 67.8% passed. Now, if you recall the problem from yesterday, it said that the population proportion was 80%. So we were trying to see if there's actually less people that pass than we say there is. So the second thing we do then is using the information from our null model, that P, the population proportion, which they told us was 80%. I'm going to calculate the standard deviation using the population parameter. So it's the square root of the 0.80 times the 0.20 over the sample size of 90, and it's a little bit more than 4%. Okay, now the final step is to calculate the z-score. And if you remember the z-score, it's the difference between your sample value or your data value minus the population proportion divided by the standard deviation of that population proportion. So here we go. You could see on the right, we took the 0.678 from our sample. That was the 61 out of 90 kids. We want to know how far it is from the population proportion, so we subtract 0.80, and then we divide by the standard deviation, and we get a z-score of a negative 2.90. So by now, I know that we do understand that anything further than 2 standard deviations away is considered statistically significant. So we do have reason to believe that there are less kids passing the driver's test than 80%. So I hope this helped. I hope this makes it a little bit more understandable, and take care.